the first thing that we're going to tackle is the ways of expressing concentration. So under the ways of concentration is the mass volume percentage. So this is how we normally write the mass volume percentage. So in general, the actual equation of it is the mass of solute in grams divided by the volume of the solution or your solution in milliliters. And because it's a percent, we were going to multiply it by 100. So yeah, that's the general solution of it. And it's very it's very important to pay attention to the units of grams and milliliters. They might give you another question that you need to convert it into milliliters and grams. But this is how it is needed to be solved. It is needed to be in grams and milliliters. So we're going to give an example. So example number 1 of mass volume percentage. So example number 1, a solution is prepared by dissolving 10 grams of glucose in water to make a 350 solution. So find the mass volume percentage. So we're going to follow the formulas, which is mass solute over or divided by the volume of the solution times 100 because of the percent. So ganito yung magiging itsura niya. Mass of solute is 10.0 grams and the volume solution is 350 milliliters. And dapat in grams and milliliters lang siya. If hindi, then we need to convert it. But this is a very basic and the most easy question under the mass volume percent. So times natin ng 100 because again of the percent, and is equals to, after we compute this, it is equals to 3.08% mass volume. So that is the total overall and the answer to the said question. So next example, and this is a much harder one. So a saline solution is 0.92% mass per volume of sodium chloride. How many grams of sodium chloride needed for a 350 milliliter solution? So this time, what we're going to do is, actually we are given the mass volume percent already and the volume. So we're going to find the grams. So this is how it is computed. So 0.92% because it is given. And since this one is missing, so it's equals to x because this is the one we're looking for, over 3.0 milliliters. And this is the part that everyone keeps forgetting. We have to also times it by 100 because of the percent, we have to multiply it. So don't forget to multiply it. So we'll just keep moving forward. So 0.92% is equals to 100x over 350.0 milliliters times 350 milliliters, or like 35.0 milliliters, I forgot, times, we're going to multiply this also by 35.0 milliliters and cancel. So in order to achieve the x, we're going to add 100. So cancel this one and I'm just going to add 100 here para mabalance sila. So after nyan makompute, ito lang natitira. So x is equals to 0.32 grams. So this is the missing grams that we're looking for. So the next topic will be the colligative properties of a solution. So under it, one of the things that is under it is the freezing point depression. So the freezing point of a solution is lower than the freezing point of the solvent that makes up that solution. So for example, the freezing point of a salt water is lower than the freezing point of just pure water. So Now that freezing point can be solved for quantitatively. So let's look at this example to see that how it could be. So number one, what is the freezing point of solution containing 85.3 grams of ethylene glycol dissolved in 1500 grams of water? So now the equation that governs the relationship between the freezing point of the solvent and of the solution is delta T sub F is equals to I times K sub F times the molality. So this is very similar to the boiling point equation, but this one is just regarding for freezing point. So our I is our factor regarding what substances are being dissolved into the solution, and when dissolved, does it associate to the particles or does it just the other one? So ionic or solid or molecular solid. In this case, our solid is ethylene glycol, which is a molecular solid. So I is equals to 1 because C2H6O2 is molecular solid and will not dissociate with or into other particles besides the one particle. So RK sub F is a constant or a freezing point depression or mole constant, and for water 1.86 degrees Celsius per molal. So yan, ganyan lang yan siya. So the next thing is, and the molality that is given is we need to calculate because it is not given in this problem. So our molality is our moles of solute per kilogram of our solvent. So yan siya. Or it's like this, mole solute then kilogram of solvent. They're the same thing. So we're going to solve that. We have to find the moles of solute. So we use the mass given to us, and we use the mass of our particular solute. Mark this one, ethylene glycol, 62.08 grams per 1 mole. Ayan. Kasi dito ko lang yung kinuha. So cancel lang to para makuha yung mole. So we're just going to compute this one using scientific calculator. Wait, I forgot something. So I'm just going to put this one because given siya, oh. So our mole goes to 0.92. So for our delta T, so I want to know what my final temperature is. So per molal, degrees Celsius per molal times 0.92 molal. Because I wanted to know what the final temperature will be. So R is equals to 1.7 degrees Celsius. So this is not the final answer. This is just the change in temperature. Again, this is not the final answer. This is just the change in temperature. So 0 degrees Celsius. To know that freezing point of solution is when it's going to be lower than. So we subtract the delta T from the normal freezing point, and we get negative 1.7 degrees Celsius as the negative freezing point of our solution. So this is the negative freezing point of our solution. Yeah, this is the freezing point solution of the ethylene glycol one, negative 1.7 degrees Celsius. So the last problem that we'll tackle about is under thermochemistry. So a part of thermochemistry is the first law of thermodynamics, which is the calculation of work, heat, and internal energy. So this is an example of a problem under thermodynamics. So number one is a gas is compressed from an initial volume of 20.5 liters to a final volume of 2.9 liters against an external pressure of 5.00 atm. During the compression, the gas releases 2.4 kilojoules of heat. So what is the change in internal energy? So ayun siya. So we'll erase this and we'll calculate and solve the equation. for this problem is the change in internal energy delta E is equals to the heat plus the work. So let's do the heat first. So Q. So we're told that this gas releases 2.4 kilojoules of heat. So right the bat, we know the magnitude of the heat given is 2.4 kilojoules. So we just have to figure out what is the sign of the heat. So we're told that the gas releases the heat, so when the system releases energy, so it was negative. So in this case, negative siya. So if it is said that the gas absorbed heat, then the key would have been positive, but in this case, it is negative. So now we can calculate the work. So we're told that the gas was initially compressed from a volume of 20.5 liters to a final volume of 8.9 liters. So the equation for work is that work is minus the external pressure times the change of volume. So ayan. So the change in volume is the final volume. So ito. So the change in volume is equals to the final volume. Is equals to like the minus the initial volume. So our final volume 8.9 liters minus 20.5 liters. So the change in volume is equals to negative 11.6 liters. So when the gas is compressed, in this case the delta V is negative. So if expanded, the delta V will be positive. So negative siya. So i-plug in natin yung work for numbers. So dito na. So pressure, so negative 5 point in atmospheres siya minus negative 11.6 liters kasi ito the volume. So when I multiply this out, I get positive 58.0 atmospheres. So in this case, it would make sense that the work is positive because when I compress the gas, the surroundings are doing work on the system, so the system is increasing in energy. So our result should be positive. The gas expands, then the system is doing the work, and when the gas expands, our work is going to be negative. But in this case, this one is positive 58.0 liter atmosphere. Right? Now, before I can add my heat and my work together, they got to have the same units. So, ayan siya. I'm gonna convert the work from liter atmospheres into kilojoules. Kasi, ganito siya. We just have to convert it. So, my conversion fact na tayo before that is given, and that is 1 liter ATM is equals to 1.13 joules. So, ito yung gagawin nating basis to compute or to convert this one. So, ganito siya i-convert. I'm just going to erase this one. So, ganito siya i-convert. So, 58.0 liter ATM times 1 liter atmosphere is equals to 1.35 joules. Then, we know that there are 1,000 joules. And 1 kilojoule. Ginagamit natin yan. So, cancel this one out. And then, I'm left with kilojoules only. So, my work in kilojoules is positive. So, i-calculate lang yan. So, the answer will be positive 5.88 kilojoules. So, what we're going to do is, we're just going to add it together. So, delta E is equals to Q, which was negative 2.4 kilojoules, plus our work, which is 5.88 kilojoules. And so, our delta E for this problem is positive 3.5 kilojoules. So, that's the final answer, 3.5 kilojoules. That's all.